Next one is magnetic properties of a metal complexes. Here, as you know already, magnetic properties of metal complexes, it can be divided into different types, but mainly here the two types are there. One is a diamagnetic, another one is a paramagnetic is there. What is meant by diamagnetic? Diamagnetic means the metal complexes whose central metal ion it containing paired electron, it is known as a diamagnetic. Paramagnetic means the metal complexes whose central metal ion it contains one or more unpaired electrons, it is known as a paramagnetic. Or simply here diamagnetic, dia means how much? There is a 2, okay, this is 1 and this is the 2. So means whether it is a paired or unpaired, obviously it is the paired. So therefore it is the substance it containing paired number of electron, then it is said to be diamagnetic. The substance it containing paired electron, it is known as a diamagnetic. And then comes forth opposite formation of this one, it leads to the paramagnetic property. Opposite formation means it containing one or more number of unpaired electron. ಒಂದು ಅಥವಾ ಒಂದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದ್ದಿತ್ತಂತಂದರೆ ಅದಕ್ಕೇನಂತ ಕರಿತೀವಿ ಅಂತಂದರೆ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಕಂಪೌಂಡ್ ಆರ್ ದ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಸಬ್ಸ್ಟೆನ್ಸಸ್. ದ ಸಬ್ಸ್ಟೆನ್ಸಸ್ ವಿಚ್ ಕಂಟೈನಿಂಗ್ ಒನ್ ಆರ್ more number of unpaired electrons is known as a paramagnetic property. Here take one example. I am taking here, that is a hexaamino cobalt 3. Another one is that is hexafluorocobaltate 3 is there, okay. In first one here, in this case NH3 it is acts as a strong ligand. Here the splitting of d orbitals into T2g and EZ sets in presence of strong ligand, that is the NH3. So it is more. Electrons first occupy the lower energy. This is the lower energy in T2g orbitals. All the 6 electrons occupy in T2g set only. Hence there are no any unpaired electron. No any unpaired electron means it says that is the diamagnetic property, because diamagnetic property means it containing a paired electron. So here also all the electrons are paired, there is no any unpaired electrons, so it says that diamagnetic property. ಇಲ್ಲೇನಂತಂದ್ರೆ ರೀ, ಅಂಡರ್ ದ ಇನ್ಫ್ಲುಯೆನ್ಸ್ ಆಫ್ ಸ್ಟ್ರಾಂಗ್ ಲಿಗ್ಯಾಂಡ್, ಸ್ಟ್ರಾಂಗ್ ಲಿಗ್ಯಾಂಡ್ನಲ್ಲಿ ಏನಾಗತ್ತಂತಂದರೆ ಎಲ್ಲ ಎಲೆಕ್ಟ್ರಾನ್ಸು ಫಸ್ಟ್ T2g ಸೆಟ್ನಲ್ಲಿ ಪೇರಪ್ ಆಗುತ್ತೆ. ಪೇರಪ್ ಆದ ನಂತರ ಮಿಕ್ಕಿದ್ದು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನಾಗತ್ತಂತಂದರೆ ಮೇಲ್ಗಡೆಗೆ ಹೋಗುತ್ತೆ. ಬಟ್ ಇಲ್ಲೇನಂತಂದರೆ ಸಾಕಷ್ಟಿದೆ ಇಲ್ಲೇ ಕೋಬಾಲ್ಟ್ +3 ಸ್ಟೇಟ್ನಲ್ಲಿ. ಸೊ ದೇರ್ ಈಸ್ ನೋ ಎನಿ ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್, ಸೊ ದ್ಯಾಟ್ಸ್ ವೈ ಇಟ್ ಶೋಸ್ ದಟ್ ಈಸ್ ದ ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಪ್ರಾಪರ್ಟಿ. Similarly you can come here. In this one fluoride it acts as a weak ligand, okay. So that's why here this is about the electrons goes into excited state, that is the EG state. Here first 1 2 3 4 5, then here sixth one is there, okay. So that's why it shows that is the paramagnetic properties, because here the number of unpaired electrons are present. Fluoride ion it is acts as a weak ligand, splitting of d orbitals into T2g set as well as EG set in presence of weak ligand, that is a F is less. Thus pairing of electrons takes place only after all 5 electrons are half filled. Only one orbital has a paired electron in this one, but here there are 4 unpaired electrons are there. So therefore here it shows the paramagnetic property, because what is the paramagnetic property? The substance it containing more than one unpaired electrons or one or more number of unpaired electrons, it containing only one paired electron, but as compared to this one it containing many more number of unpaired electrons. So that's why it shows that is the paramagnetic property. Next one in this one is here, calculation of magnetic moment using Gauss method. Calculation of magnetic moment using Gauss method. Here you take one weighing machine. This is the first one diagram. second one diagram, third one diagram. Okay, so it is as it is a common and it is in presence of magnetic poles. Okay, here the above side is there and it is the lower side is there. The paramagnetic or diamagnetic nature of a given substance, it can be measured by using the Gauss method. ಒಂದು ಕೊಟ್ಟಂತಹ ಒಂದು ವಸ್ತು ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಐತೋ ಅಥವಾ ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಇದೆಯೋ ಅಂಥೇಳಿ ನಾವೇನು ಮಾಡ್ತೀವಿ ಅಂತಂದರೆ ಗಾಯ್ಸ್ ಬ್ಯಾಲೆನ್ಸ್ ಮೆಥಡ್ದಿಂದ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀವಿ. ಹಿಯರ್ ಫಸ್ಟ್ ಒನ್, ದ ಸಬ್ಸ್ಟೆನ್ಸ್ ಈಸ್ ಟೇಕನ್ ಇನ್ ಎ ಸ್ಮಾಲ್ ಟೆಸ್ಟ್ ಟ್ಯೂಬ್. ದ ಸಬ್ಸ್ಟೆನ್ಸ್ ಇಟ್ ಈಸ್ ಟೇಕನ್ ಇನ್ ಸ್ಮಾಲ್ ಟೆಸ್ಟ್ ಟ್ಯೂಬ್ and it is weighed in the absence of magnetic field. Weighed in the absence of magnetic field. And next one, it is weighed in presence of magnetic field. It is weighed in presence of magnetic field. Here, if the substance it shows increase in weight, this is implied that the substance it is attracted by the magnetic field. It is attracted by this magnetic field. Then it shows that is a paramagnetic property. It shows paramagnetic property. The larger is the number of unpaired electron in a substance, the greater is in increases in its weight in the magnetic field. And in next one, if the substance shows decrease in weight, if the substance shows decrease in weight, it implies that the substance it is repelled by the magnetic field. Substance it is repelled by magnetic field and hence it shows the diamagnetic. Or in common, which substance it is attracted by the magnetic field, it is says that is the paramagnetic property. And which substance it is repelled by the magnetic field, it is attracted by the magnetic field and it is repelled by the magnetic field, then it shows that is the diamagnetic property. ಯಾವುದು ಒಂದು ಅಟ್ರಾಕ್ಟ್ ಆಗುತ್ತಲ್ಲ ಅದಕ್ಕೆ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಪ್ರಾಪರ್ಟಿ ಅಂತ ಕರಿತೀವಿ ರೀ. ಯಾವುದೊಂದು ರಿಫೆಲ್ಡ್ ಆಗುತ್ತಲ್ಲ ಅದಕ್ಕೇನಂತ ಕರಿತೀವಿ ಅಂತಂದರೆ ಡಯಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಪ್ರಾಪರ್ಟಿ ಅಂತೇಳಿ ಕರಿತೀವಿ. ಸೊ ಹಿಯರ್ simply increase in weight, it is attracted by magnetic field and it is a paramagnetic. Decrease in weight, it is repelled by the magnetic field, then it is a diamagnetic property. It can be calculated by using this formula. Here mu is equal to root of n into bracket n plus 2. Its unit is Bohr magneton. Here n it stands for the number of unpaired electron. Here for n is equal to 0. n is equal to 0. Mu is equal to root 0 into bracket n value 0 plus 2. Here its value is 0. For n is equal to 1, mu is equal to root of 1 into bracket 1 plus 2. Here the 1 and then this is 3. 3 into 1 is root 3. Root 3 it is nothing but around the 1.7 Bohr magneton is there. One hence you have to use here. If the number of unpaired electron 1, then its answer is 1 point something. If the number of unpaired electron is 2, then your answer will be that is the 2 point something is there. And then suppose it is n is equal to 3, your answer will be 3 point something is there. So this is about the calculation of magnetic moment by using a Gauss method.